Okay, just doing a little bit more with these outcomes. First of all, let's notice that 1 has an empirical probability of 0. 1 could not occur. The smallest number you can get on 2 dice is 2. Okay, now, having shown these probabilities, we can make a graph representing these empirical probabilities. Okay, the axis here goes from 2 through 12. I can put 2 in there, I guess. 3 comes right next to 2, and we go up to 12. And the empirical probabilities for 3, 6, 7, 8, and 9 are all 1/10. So we make a little vertical line representing a probability of 1/10 here, 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 and here. Okay. Now for 5, we've got a probability of 4/10. So we're going to make the number for 5, and I haven't labeled the 5, I've labeled the 6. We can see that that's 5. So your empirical probability is 4 times as high as it is for any of the others. So there is your empirical probability of 4/10. Now the ideal for rolling 2 dice, as we should know perfectly well by now, there's 1 way out of 36 to get a 2, 2 ways to get a 3, 3 ways to get a 4, 4 ways to get a 5, 5 ways to get a 6, 6 ways to get a 7, then 5 ways to get an 8, 4 ways to get a 9, 3 ways to get a 10, 2 ways to get an 11, and 1 way to get a 12. So here's our ideal probability distribution for rolling 2 dice. And the empirical does not agree very well with the identical. And that can certainly occur. On only 10 rolls, some of the outcomes aren't even going to occur, and 10 rolls is a pretty small sample, so all kinds of strange things can happen. If we did 1,000 rolls and didn't come out with something pretty close to this, we would figure that there's something wrong with our table, if we're doing a simulation by the table, or there's something wrong with our dice. Now these tables kind of lead us to transition to the next chapter on statistics, where we'll look at probability distributions, graphs of probability distributions, and so forth. So it's something you want to kind of begin to familiarize yourself with, and this constitutes a pretty good example of how we might graph probabilities and get this thing called a probability distribution. We'll make that more concrete in the next chapter on statistics.